This video covers Lesson 2-7 for Secondary 1 Math, solving quadratic and cubic equations. Number 1. X represents x times x, because x squared means that we have two x's being multiplied together. Number 2. The square root of x is asking the question, what number times itself is x? So again, what number times itself is x? Number 3, principal square root is only looking for the positive number. So below you see this example. -4 times -4 is 16. But we also see that 4 times 4 is 16. But when we find the square root of 16, or we're evaluating the expression of square root of 16, we are only wanting the principal square root. So we only write 4. Number 4. The square root of -16 is undefined. So if we exclude this sign and just think of what's there, it's 16. And the things that give us 16 would be -4 times -4. But that's not equal to -16, because even above we have -4 times -4 is positive 16. And well, what about 4 times 4? But 4 times 4 is also positive 16, so that's not equal to -16. And these are the only two possibilities we know of that could give us a 16, and neither of them give us a -16. So there's no possible solution here from our real numbers, so we say it's undefined. And it's not an isolated situation. If we look at number 5, we have the square root of -100, which is also undefined. And this is because the same situation, -10 times -10, does not equal -100. It equals a positive 100. Or 10 times 10 would also give us a positive 100, not -100. So again, we reiterate this point, that there's no possible real number when multiplied to itself will result in a negative number. So this point is something important to add to number 2. So we're going to add on to number 2, and we're going to say that there is no number times itself is negative. So going back to that last part underneath number 4, it says, remember, when we are solving an equation, you're asking yourself, what number or numbers can I substitute in for the variable and have both sides equal each other? When solving a quadratic equation, we are looking for all the solutions. So just like -4 times -4 is 16 and 4 times 4 is 16, we're not just looking for the principal square root when we solve the equation. We're actually looking for both 4 and -4. Number 6, solve the quadratic equation. So we're going to solve and write the answer in set notation. So the opposite of taking x squared would be taking the square root of it. So we're going to take the square root of x squared and the square root of 81, which gives us that x is equal to 9, but also -9. So we can put a plus or minus in front of this, because it could be positive 9 and -9. Because -9 times -9 is 81, and 9 times 9 is 81. Now we want to put this into set notation, and there's a couple different ways. So the first way, using always the braces, we're going to say the set x such that x equals positive and -9. Or we could separate it and say the set x such that x equals 9, and the set x such that x equals -9. Okay, so number 7, again we have an m to the second power. So here we're going to take the square root of both sides of our equation, and the square root of m is m, and the square root of m squared is m, and the square root of 121 is positive and -11. To find that result of positive and negative 11. If we used our calculators, we would take the square root, so we would go second. So again, this is in a TI 30. We go second, and then we would use the x squared button right above it. You see the square root, and then we would type the number in that's inside our square root and hit enter, which would result only in the positive 11. But again, like we showed above, there are two possible values here, a positive 11 and a negative 11. So we get m is equal to positive and negative 11. To put it into set notation, we would have the set m such that m equals positive and negative 11. We could write it separately and say that the set m such that m equals 11, as well as the set m such that m equals negative 11. Okay, number 8. So again, we have 225 equals b squared. So we have a variable squared. To undo that, or do the opposite of it, we take the square root of both sides of our equation, and we get that b is equal to the square root of 225, which is 15. So we're going to have positive 15 and negative 15. So writing it in set notation, we have a set b such that b equals positive and negative 15. Or we can write it separately and put the set b such that b equals 15, and the set b such that b equals negative 15. So just a reminder, these two have to be put together, and these two have to be put together, and these two have to be put together to make it complete. Or we can just write it with what's outlined here in yellow, with the plus or minus in our set notation. Okay? Alright, so number 9, w squared equals 1. Well, we're going to take the square root of both sides, so the square root of w squared and the square root of 1, and we find that w equals positive and negative 1. So in set notation, the set w such that w equals positive and negative 1. Or we can write it in two set notations and say that the set w such that w equals 1, and I'll put an and in here to make sure this is clear, the set w such that w equals negative 1. And those have to go together to make it complete. Right. Number 10. So we have 49 equals c squared. So again, we're going to take the square root of both sides, because we undo or do the opposite of squaring c. So we get c on the right side. On the left, we're going to have positive and negative 7. So we're going to write the set c such that c equals positive and negative 7. Now we could write it in our two separate ones again, so the set c such that c equals 7, and the set c such that c equals negative 7. This is just a notation difference, okay? And again, I would stick with those that are outlined in the yellow. These were the ones I would write to make it a little simpler. Okay, number 11. We have k squared equals negative 196. So if we take the square root of both sides to undo the squaring of k, we get that k is equal to, we get that k is equal to the square root of negative 196. But as we talked about before, we cannot take the square root of a negative number. There is no number multiplied to itself that gives us a negative number. So this indicates that there is no solution here. So k has no solution. Okay. And we use set notation is the empty braces. Alright, number 12. So now we're moving on to our cubes. So we have x cubed. Well, just like x squared was x times x cubed is just going to be x times x times x. Here indicating that we have three x's being multiplied together. Number 13. The cube root of x is asking the question, what number cubed or times itself twice is x? So what number cubed or times itself twice is x? Now, 14. We have the cube root of 8, which is 2, because 2 times 2 times 2 is 8. And the cube root of negative 8 would be negative 2, because we have negative 2 times negative 2 times negative 2. Multiplying these together, negative 2 times negative 2 would give us a positive 4. And if we multiply that by negative 2, we end up with negative 8. With this example, we see that we can have negative numbers inside cube roots. So let's write this down on number 13. We can have negative numbers in cube roots. So make sure you have that down on your paper. Number 15. We're going to solve these cubic equations, and we're going to write answers in set notation. So like when we solved our quadratic equations and took the square root of both sides, here we're dealing with cube roots. So we're going to take the cubic root, or the cube root of both sides of our equation, which gives us that v is equal to 7. Now, let's just take a second and remind ourselves, if I were to do negative 7 times negative 7, there we go, times negative 7, negative 7 times negative 7 is 49, so we get a positive here. And when I multiply by a negative again, we would end up with a negative 343, which is not what we have up here in our cubic root, or what we're taking the cubic root of. So it's a positive here, so we have to have positive 7 only. So putting this into set notation, we say that the set v such that v equals 7, and only positive 7. Okay, number 16. So we have m to the third power equals negative 343. So again, we're going to take the cubic root, or the cube root of m cubed, and the cube root of negative 343. Well, that gives us that m is equal to, and here we have negative 343, which is what we saw in the green on the left here, which gives us negative 7. Not positive, only negative. So we would say the set m such that m equals negative 7. Okay, number 17. W to the third power equals negative 125. So again, we're going to take the cubic root of both sides of our equation, and which results in w being equal to negative 5, since it's a negative 125 in the cube root. So putting it in set notation, we say that we have this set w such that w equals negative 5. Number 18. X cubed equals 64. Again, we're seeing this cube, so we're going to take the cube root of both sides of our equation, and we get x is equal to 4. And it's only positive because the 64 in the cube root is positive. So our set notation, the set x such that x equals 4. On number 19 and 20, we're going to do the same thing. And so we have p cubed. I'm going to take the cube root of p cubed and the cube root of 216, which gives us p is equal to positive 6. So we would write this as the set p such that p equals 6. And then number 20, m cubed equals negative 729. So again, take the cubic root or cube root of both sides, and we have m is equal to negative 9. And so writing that in set notation, we say the set m such that m equals negative 9. And then we close with our brace. This concludes this video covering Lesson 2-7 for Secondary 1 Math, solving quadratic and cubic equations.